Hi, my name is Ewan, and I'm a senior on Titan Robotics.
I'm Nicole, and I'm a freshman on Titan Robotics.
And we're excited to teach you about sound today.
What is sound? Sound is vibrations that travel through the air or another medium and can be heard when they reach an organism's ear. Sound is typically invisible but can be represented or modeled in other ways.
So, who discovered how sound works? Well, the answer is many scientists have made contributions to the field of acoustics, which is the name of the scientific study of sound. As early as the 6th century BC, in ancient Greece, the philosopher Pythagoras, who is also known for important discoveries such as that of Pythagorean theorem, made discoveries involving vibration of strings to create music. In the 4th century BC, Greek philosopher Aristotle theorized that sound travels in waves. The modern study of acoustics is generally attributed to that of Galileo Galilei in the 16th century, who identified a correlation between frequency and pitch. Robert Hooke was the first to produce sound waves of a known frequency in the 17th century, and in the 1660s, Robert Boyle proved that sound needed a medium to travel through. The equation for waves themselves was finally developed in the 1740s by Jean de Ronde-Delert. Sorry if I said that a little wrong. I'm not a native French speaker. So, the short answer for who discovered sound is a whole lot of people. Many more people that we included in this section. And if you would like to look here, here are the names of the people that we listed, and of course, the definition of acoustics.
Different types of sound waves. Sounds can have many different characteristics. What differs these sounds from one another is their waves and wavelengths. There are two types of waves, longitudinal waves and transverse waves. Longitudinal waves are waves in which the particles of the medium vibrate back and forth in the same direction in which the wave is moving. Think of a slinky, for example. Compressions or bunched up waves are moving along the slinky. But when one part of the slinky compresses, another part spreads out. Transverse waves, however, are waves vibrating at right angles in the direction of it travels. It doesn't bunch together with compressions. It simply peaks, then lowers. Think of it as ripples in water or vibrations in guitar strings. How sound travels through objects. Sound waves need to travel through mediums such as solid, liquids, or gases. The sound waves move through each of these mediums by vibrating the molecules in the matter. The molecules in solids are tightly packed together. Because of this, sound travels the loudest or vibrates the longest in solid objects. Sound travels about 4 times faster and farther in water than it does in air.
So, what if we want to test sound waves traveling through a solid? Well, today we have a fun craft for you that shows how sound can travel, in fact, through a solid. So, what we're going to make today are tin can telephones, all right? So, first, before we start, we need to make sure that we have all the supplies here, all right? So, first, make sure that you have 2 cans. Preferably, cans like this are usually a little better than this. I just had one tomato sauce can and a cat food can, so that's what we're working with today. Make sure that you have some string. So this is actually not two separate pieces of string, but actually one very long piece of string that is a little too long to fit all in the camera here. We need a nail and a hammer, all right? So first here, you're going to want to ask your parents for help doing this part right here, because this first part here, we're going to use the nail and the hammer to punch a hole through the can here, all right? So make sure you ask a parent for help right here, because this is a little harder, all right? And we want to make sure that everybody's staying safe. So first, what we're going to do is we're going to take our hammer, we're going to take our nail like this. We're going to punch a little bit of a hole here, all right? We're going to twist it around to get it out. All right, see, now we have a hole, and we're going to do that on the other cam. It could be a little deeper. All right, now we have a hole over here. We have to put the string into our cam hole, all right? So what you're going to do is we're going to take our string and we're going to put it through, coming from the side that has the full face still. All right, you're going to take it, you're going to push it through, right? You're going to pull it through here. So see, you can now see that the string is all the way through. And now what we're going to do is we're going to tie a knot here, all right? So you pull it out of your can a little bit. I'm going to tie a nice knot. All right, Now that you have your knot, what's going to happen is when we pull this back through, the string is not going to come all the way. See? So that's very important here. We don't want our string to fall out. All right, and then you're going to do that on the other can, okay? So once you have put the string through on both cans like this, now you have your tin can telephone. So how will this work? So how it works, it's pretty simple. One person will stand and speak into it like this. The other person will stand far away and have this side and hold it up to their ear, and you'll be able to hear out of it. So just to make sure that it works, make sure that you're holding it in a way that the string is tight between you. So usually this works best if you stand on opposite sides of a large room or on opposite sides of like a backyard. So that way you make sure that your string is nice and tight. Make sure your string is not contacting any of the other surfaces. So if you're using it in a house, make sure that it's not resting or being pulled against the table. Otherwise, the table will disrupt the vibrations going through the string. All right. So what you'll do, stand far apart and then speak normally into the one end and have the other person listen to the other end. All right. Please make sure that between every use of this, that you're making sure that you wash your cans. These are being held up to your face. We want to make sure that we're not spreading any germs right now. Other than that, though, have fun with this, and I hope you enjoy this activity. Thank you so much for watching today, and have a great rest of your day.